Today I am going to explain the experiment 4 of physics 2, electrical resistivity. My dear, you will study this concept in chapter number 26 of physics 2. Clear? Actually, electrical resistivity should indicate with a letter rho. Here rho is not a density, here rho indicates the electrical resistivity of some material. My dear, actually each and every material has its electrical resistivity value. So today, what is our objective? If you just read our objective, we are going to measure the resistivity of the graphite used in the pencil. That means today we are going to use this pencil. We are going to use this pencil. And if you just see the pencil, the black color is nothing but the graphite materials. So we are going to find the electrical resistivity of this black color. The black color is nothing but the graphite materials. Clear? So today the main apparatus is our pencil. So we are going to calculate the electrical resistivity rho value of this pencil lead, which is black in color. And then we are going to find the thickness of the pencil line. So I will explain these things later, because in this experiment you are going to fill two tables. So first table we are going to find the electrical resistivity. In the second table I will explain how to find the thickness of the pencil line. Clear? So for this we are going to use this equation. What is this equation? Resistance, which is equal to rho multiplied by L over area. And if you just area is nothing but it's a formula pi r square. So if you just see the cross section of this pencil lead, it is like a circle in shape. So what is the area of the circle? It is nothing but pi r square. So if you rewrite this equation, what you will get? R, which is equal to rho L over pi r square. Clear? So here r square is nothing but r. What is r? If you want to get the r, if you know the diameter, you can easily divide the diameter by 2, you will get this value. So here, how I can write this r square? I can write the r square as d square over 4. So I can write r, which is equal to rho L over pi d square and over 4, and this 4 will come and sit here. And now, what is our objective? We are going to find the resistivity. So rearrange this equation. So if you rearrange, what you will get? If you rearrange this equation, rho, which is equal to this pi d square, will come to the left hand side of the numerator. So pi d square multiplied by r divided by 4L. So this is our equation for our first table. Clear? So what is our first table? Our first table is given here. We are going to use that formula here. So if you want to calculate the resistivity, you can just have a look at the formula. If you want to calculate the resistivity, what are the things you need? You need the resistance of the black color pencil, and then you need the length of the pencil, and you need the diameter of the pencil lead. So all these three is very, very important for finding the value of rho. Clear? So what I am going to do? First, we are going to find the length of the pencil from this black edge to this black edge. So I have a ruler. I have a ruler here. You can just have a look here. From this black edge to this black edge. What's the value, my dear? It's exactly 11.2. Am I right? You can see here. It's exactly 11.3. So the value of the pencil from this black edge to this black edge is 11.3. But this is in centimeter. But if you just see the paper, they ask you to write the value in terms of millimeter. That means if you multiply by 10, you will get the answer of centimeter in terms of millimeter. Our centimeter for the length of the pencil is 11.3. When you multiply by 10, you will get the answer in terms of millimeter, which is nothing but 130 millimeter. So what is the length of the pencil in millimeter? 113 millimeter. And then we have to find the diameter of this black color. My dear, universally, if you go in anywhere of the country here, the pencil lead diameter is exactly 2 millimeter. If you go to any country, if you buy any pencil, the diameter of the black color is 2 millimeter. So I am going to write 2 millimeter because this is the universal number. And now you need resistance. That means you have to use the multimeter to find the resistance between these two black edges. So for that, what I am going to do, I'm going to use the multimeter. This is our multimeter, and you can see here there are different functions. And center we have one knobs, and this knob indicates the arrow mark, and we are going to find the resistance. The unit for the resistance is ohm. So I fix my arrow marks towards this ohm. So now what I'm going to do, if you see this, we have two sharp needles here. I'm going to put one needle to the first black edge to the right hand side. I put the another needle to the left hand side. Okay, now you can just have a look here. I'm going to hold just see the value, the resistance of the pencil. I think it's very close to 11. Because the edge is not proper. So wait, again I will just put my sharp needle to both edge and see the screen. You can see the monitor. Just a minute, hold for a few seconds, and after sometimes the reading will be stopped. So that means 9.4 or 8.8 exactly. So the resistance of this pencil lead is 8.3 or 9. I forgot, sorry.
8.8.
8.8? Okay, 8.8. Clear? So we got the value here. After sometimes the reading, but if you need, you can just measure again, because I forgot. I will do it again. Because the edges are blended. Just you can just have a look of this screen. So again I measured, it shows 7 point something. I think previously we made a mistake. It's exactly 7.0. Clear? So the resistance of this pencil lead is exactly 7.0. So I can just cancel this. 7.0. Now you can see you have all the values. This is our main equation. You got the diameter value, you got the resistance value, you got the length of the pencil value from the black to black edge, and then once you substitute the value here, you can easily get the answer for the resistivity. Clear? So you have to use this equation. So this equation is very, very important. Clear, my dear? So after we find the resistivity by using this formula, we have to find the second objective. Actually, when you just read the objective, we have two objectives here. The first objective is to find the resistivity, and the second objective to find the thickness of the pencil line. So what is this thickness of the pencil line? That means you are going to draw something on the graph paper. Clear? So this objective we already finished. Now we are going to get some idea how to measure the thickness of the pencil line. That means you are going to draw a line on the graph paper, and you are going to find the thickness of the graph paper, thickness of the shading line. So for this you have to fill this table. So how much time, how much length is given? You can see it starts from 20 millimeter. 20 millimeter is nothing but 2 centimeter. 2 centimeter to 16 centimeter you have to make a line. So for that, what you have to do? You have to take your graph paper and you have to choose one box. You have to choose one box. And from the center of the box, you have to choose two small box. You can see each small box on the graph is 1 millimeter. So first you have to choose one big box, and then you have to take your ruler from the center of the box of 16 centimeter. You have to draw a line with two small box. You can just have a look here. This is our center of the box, and this is my 16 centimeter. So I'm going to draw the line here. The length of the line is exactly 16 centimeter, and I have to choose two small box. That means my width of the line is exactly 2 millimeter. You can see each small box. So I have to, if you see inside this line there are two small boxes. That means the width of the pencil line is exactly 2 millimeter. So this width is nothing but 2 millimeter. So what you have to do, after you draw this, you have to shade this perfectly by using this lead, this black color, which is nothing but the graphite materials. So what you have to do, you have to take your pencil, you have to shade this box and also this pencil line perfectly. If you make any space between these, you will not get the reading in the resistance box, because you are going to measure the resistance. So if you just see this, the center of the box is exactly counted as 0, and for every 20 millimeters, which is nothing but 2 centimeter, this is your 5, 10, 15, 20. So that means this is your 20, 5, 10, 15, 20. That means each small box is 1 millimeter. So you have to draw this type of line. You have to shade completely by using your pencil. Once you shade, this will be like this. You can just have a look here. And I already marked the number. 0, 20, 40, 60, 80, 100, like that. So the total length of the line from the center of the box is 16 centimeter, which is equal to 160 millimeter. Clear? Now what I am going to do, again I am going to use the multimeter, and I am going to use the multimeter in resistance mode, which is nothing but ohm. The unit for the resistance is ohm. So what I am going to do, you can just have a look here. This is our shading line. I have to put one sharp needle to the center of the box. So we have to put one sharp needle to the center of the box, and you have to place your second needle to 20. You can just see 20, 40, 60, 80, like that. So place one edge, one sharp needle to the center of the box, and you have to place your second needle to 20. Now just have a look of the screen of the monitor. You can just see for this 20 millimeter, what's the reading, my dear? Just to see this monitor. What's the value? After some times it will be stopped. You can just have a look here. This is 24.3. The readings are rounding on the same value, 0.3 something. So 24.12 or 15, I'm going to take 24.48, just to take one reading. And you can see that is in mega ohm. You can see the screen. It is given in terms of mega ohm. Capital M is there. You can just have a look here. If you just have a look here, this side, you can see it is in mega ohm. You can just have a look here. Just a minute. Which is 24 point, I'm going to write one reading, 25.32 mega ohms, 24.52, 24.52 mega means 10 to the power of 6. Okay, so this is the reading for 20 millimeter. So when you want, if you want to find the answer for the 40, then you have to place the first needle to the center, and you have to place your second needle to 40. So that means for every 20 you are going to take the reading. So but this needle you have to keep it as constant. You have to place the first needle exactly to the center of the box. You have to only move this. 20 we already find. When you put the needle in the 40, the reading will change. Then after that 60 you have to measure. After that 80 you have to measure. After that 100. Likewise you have to measure the resistance value for every 20 difference. Clear? So if you just take the reading, you can completely fill this thing. So for every 20 difference, you can fill the table. So after you fill, you have to draw the graph. For what you are going to draw the graph, just to have a look here, you are going to draw the graph for R versus L. That means R value y-axis, L value in x-axis. So I have to draw the graph here. R value, and it is in mega, so I can take this value as common because all readings in this table will comes in terms of mega ohm, and the unit for this resistance is ohm, and L value, it is in millimeter, so I can write 10 to the power of minus 3 because millimeter to meter, it's in, you have to multiply by 10 to the power of minus 3, and the unit is meter. Now with the help of this reading, you have to draw the graph, fix the point, connects the points with a straight line, choose any 2 points on the line. This is your x1 value, this is your x2 value, this is your y1 value, this is your y2 value. So slope is delta y over delta x. So y-axis we took R, x-axis we took L value, so that means R over L is the slope. Now after you find the slope, where we are going to substitute the value. So this is our equation. Where is this equation? For the second table, we are going to use this equation. So how we got this equation? Previously I told you R, which is equal to rho multiplied by L over area, am I right? So I can write the area in terms of width multiplied by thickness. So I can just write the readings here near to the graph. R, which is equal to rho multiplied by L over width multiplied by thickness. We are going to find the thickness, so rearrange this equation in terms of thickness. So T, which is equal to rho L over W R. So here our slope is R over L, but what we have here it is L over R. So now how you can write? T, which is equal to rho over W multiplied by 1 over slope. So take the slope value, substitute here, and what is this rho? This rho value, you have to convert this in terms of meter. After that you have to take this value, you have to substitute the value here. Clear? Because we need the answer of thickness in terms of meter. So if you want to get the answer in terms of meter, you have to substitute the value of the resistivity in terms of ohm meter. So you will get one answer, just multiply by 10 to the power of minus 3, that's it. Clear? And also, what is the thickness? What is the width? Because if you just see the line, the width of this line is exactly 2 millimeter. So the width of the line is exactly 2 millimeter. So width is 2 millimeter meter. So 2 millimeter, when I convert this millimeter to meter, I have to multiply by 10 to the power of minus 3. So take the value, substitute here, take the resistivity value from the first table, and take the slope value, substitute here, you will get the thickness. My dear, generally the thickness, the paper thickness is very small. The paper thickness is very small. And in this paper, you made some layer of coating, am I right? So if you want to measure the thickness of your coating, it will be less than the thickness of the paper. So your answer must be in terms of 10 to the power of minus 8 or 10 to the power of minus 9. Your answer must be in terms of 10 to the power of minus 8 or 10 to the power of minus 9. So if you got the answer in that level, your answer is correct. Clear? Because why? The paper thickness is already, it's a very small size. So in this paper, you made this layer. That means you are depositing the atoms here. So what is the layer of this atom thickness? The atom thickness layer is very, very small. So once you substitute the value here, your answer must be in terms of, you will get some answer, multiply by 10 to the power of minus 9 or 10 to the power of minus 8. So that's the procedure for this experiment. That's the procedure for this experiment, electrical resistivity. That's it. Clear? Thank you.